This video is my top tips for learning statistics. I've been teaching maths for many years, making notes after every tutorial basically, and this is my kind of consolidated top tips based on my experience of teaching, things that students have found most useful that I've showed them. Okay, skewness, often taught very confusingly. Here's a really clear, simple explanation. Oh look, on the left it's positive skew, or right skew, because points have been there's more points towards the right or in a positive direction. Oh, let's look at the next slide. Histograms. Oh, so much technical language making it sound confusing. Well, the simple version is width times height is how many? Or let's use technical vocab. Width of interval times frequency density equals frequency. Whatever. Anyway, sometimes you have to use these fancy words to keep people happy. A and B are independent if this is true. That's it. We're going to talk more about that later. Remember, you use a bar chart for categoric data, which you can kind of see because when you look at the bar chart, they're separated, kind of indicating the numbers don't make any sense, and so that could be potatoes, carrots, and onions, who knows. And a line chart is used for continuous data. Something else just to think about? An explanatory variable. It's more of these words that we're kind of expected to know. That's kind of what you start with, or where you start. And then the response variable, that's the thing you measure changing. Okay. Normal distribution. I love this. I think this is really simple. Look at this graph here. That's the mean, and then it just kind of jumps one standard deviation plus another standard deviation, and it carries on, and then you can minus one. So standard deviation is just a measure of like its width. Anyway, you can then use this equation up here. Mu is the standard deviation, which you can find from the question. I just said that wrong. I meant sigma. Right, that's sigma. Sigma is the standard deviation, which you can get from the question or whatever. Mu is the mean, which you can calculate or get from the question. X, that's just a particular value that you've been told. And as long as you just put those in, then Z will be the relative position on a normal distribution. Did that make sense? Maybe, maybe not. At this point, I'd normally go through lots of examples, but I don't want to do that here because I'd rather go faster. So all I'd say is, if you are struggling with normal distribution, just try and just keep thinking about it in terms of this equation. Okay, next. NCR. That's the number of ways of choosing R from N. NPR, that's the number of ways of arranging R from N. Boom, simple. If you want an extra way of thinking about it, the number of permutations is going to be generally greater than the number of combinations, or at worst case equal to. And that's because when you do permutations, it doesn't matter what order they're in, but in combinations, it does matter. So, yeah, the order doesn't matter for combinations. So therefore, there's going to be less of them. Next. Oh, it's just some words we have to learn. The mode is the number there's most of. Median is the one in the middle. Mean is the average. Struggling to remember what mean means? I always think it's the meanest one to calculate. And there's two other ways of writing mean. Oh, geez, why do we have to make it so complicated? Well, yeah, as we said earlier, that's the standard deviation. And you can square it to get the variance, which literally means it's basically a way of measuring the spread. And later on, we're going to see these two again, but let's not worry about that now. They're just different ways of writing mean and variance. Oh, in fact, here they are now. The mean and the variance can be changed. So let's look at these graphs. Let's suppose this graph on the left is the one that we start with. And then we times every value by A, and we add B to it, which means they're going to get large, they're going to spread out more, and they're going to get raised. Okay, so the whole thing's been raised up and it's been spread out. So obviously, the mean has got larger because everything's been multiplied, and it's got larger because we're adding something to each one. But the variance doesn't care where it is, it only cares about how much it varies. So we multiply it by a squared because of maths reasons, but we don't have to add the b as well. Okay, this is a summary if you're already familiar with the topic. If you're not familiar with the topic, this isn't going to make any sense. Maybe come back to it. This is how I always remember that the probability is represented by p, because if you sum them all up, it equals 1, because all probabilities will add up to 1. And this is how I remember that f means the cumulative probability function, because f of the maximum value is 1, because eventually once you reach the maximum possible value, the cumulative probability must be 1 because all the possibilities have happened. And I'll leave you to work these out yourself. Maybe pause the video if you want. There's 3 examples here of some weird maths you can do using f and p. And by the way, I'm always assuming that the probability of 0 is 0 for these examples. Yeah, I said I was going to come back to this dependent-independent thing. What does it actually mean for A and B to be dependent? I find most students don't actually know, so I just want to go through it here. So, A and B might be independent, or they might be dependent. So, let's just look at the case where they're dependent. Maybe A makes B more likely, or maybe A makes B less likely. Or maybe the fact that B has happened means A is more likely, or the fact that B has happened means A is less likely. Can we just pick one? So suppose the bus is late, that means you're going to be more likely to be late to work. There you go. It's also maybe A and B are both more or less likely because of C. That might be, okay, what's the probability of wearing a coat and what's the probability of having an umbrella? Well, they're both made more or less likely by whether it's raining. So they might be dependent on each other. And it might even be that if you're wearing a coat, you're more likely to be using an umbrella. And yet, that doesn't really make sense, because if you've got an umbrella, you don't need a coat. Anyway, it's a rabbit hole, but there you go. So that's an idea of what dependent means. But if something's independent, then there's no relationship between them at all. The fact that one of them's happened, who cares in relation to the other one? Some quick regression examples. 0.8, that's kind of, so they're quite closely correlated. If r is 0, that just means the numbers are all over the place and there's no pattern at all. And if it's negative, it means if the correlation is negative, or r is negative, then they're still correlated about the same as plus 0.8 was, but with a negative slope. Here's our last page. Ah, yes. Okay, brace yourself. Let's look at one example first. How many different looking arrangements of the letters of the word telegraph can you make? Well, the answer is 9 factorial divided by 2 factorial, and you divide by 2 factorial to remove the repeats of because there's 2 e's in there and they're indistinguishable. And the 9 factorial comes from the fact there's 9 letters. Okay, what if it has to start with a p? Well, then it'll be 8 factorial divided by 2, because you can just literally ignore the p. So you're like, well, I'm stuck with a p. All I'm doing now is trying to fit the remaining 8 letters on in lots of different ways. There we go. What if the e's have to be next to each other? There's a trick to this. You treat the e's as a single letter, which then means the answer is just 8 factorial, because then there's 8 letters. How many 4-letter words you could make? And let's assume you can have a maximum of 1 e per word. Well then you've got 8 possible letters, and you're trying to find the number of permutations which have 4. And so on. Wow. I feel like, if you're doing an exam, I feel like examiners are almost competing to make these questions as awkward as they can. So what I generally do with my students here on this topic is we just go through a lot of example questions, so they're just used to lots of the different things that can come up. Because I think, however naturally gifted you are at maths, some of these can just be really awkward, because there's been questions where I've just kind of looked at it and tried and tried and tried, couldn't do it, and then I've looked up the answer and I've gone, oh wait, what? You just had to do. Oh, I just didn't see that. And that's not normal for me. I can normally kind of work my math stuff out if I spend long enough on it. Anyway, there you go. That's kind of my top tips. I know it's quite fast. If this is on YouTube, please try not to give me a downvote if it was like too complicated for you. But maybe leave a comment saying, "Oh, I think this might be good." If you're more advanced and you want like a review tutorial scenario, and if it's more complicated, try and find some simpler videos. In terms of statistics, I don't have many videos that I've made. I've decided to just do this one review one because I think it's kind of a bit of a gap in the market where I think that it's useful. For example, one of the reasons I did this is because I often don't tutor statistics for a few months because sometimes someone doesn't want it, and I'll re-watch this before I do a statistics tutorial just to kind of quickly get back into it. Anyway, hopefully that was kind of useful for you. Thanks for watching.